Hello everybody, welcome into another lesson. So today we are going to do a 3-lesson unit on factoring polynomials. And in today's lesson we are going to factor a sum of two cubes and a difference of two cubes. Much like you can factor a difference of squares, you can factor both a sum and a difference of cubes. Let's start with the sum of cubes. So if you have two terms that are both cubic, raised to the third power, such as x to the third plus y to the third, there's an easy way to factor it. So you're going to start with taking each term. You'll have a quantity here. So take the cube root of x cubed, that of course would just be x, plus you'll take your cube root of y cubed, well that would just be y. So you'll have the quantity of x plus y. Now here's where it gets fun. Take your first quantity, and to form your second factor, you'll square your first term. So x squared is, well, x squared. Then you're going to multiply the two terms, x and y. Well, that would give you xy, but you always negate that multiplication. So you'll take the negative of x multiplied by y, so that would give you x squared minus xy. And then you'll take that second term to the second power, so plus y to the second power, that'd be plus y squared. So to factor this, you would get x plus y times the quantity of x squared minus xy plus y squared. So for a sum of cubes, again, if you have two terms that are both raised to the third power, you'll just take the cube root of each term and add them together for your first factor, your first quantity. To get your second factor, you'll take the first term of your first factor, raise it to the second power, and then for your next term, you'll take the two terms of the first factor, multiply them, and then negate that, and then you'll add the second term raised to the second power. Now, it works much the same way with the difference of cubes. So, if I have one term raised to the third power subtracted from another term raised to the third power, such as x to the third minus y to the third, it's going to work much the same way. So, we're going to take the cube root of each of these. So, what's the cube root of x to the third? It's just x minus the cube root of y to the third. Well, that would be y. So this time you'll have the quantity of x minus y for your first factor. And then we're going to get our second factor. So take your first term and square it. Your first term is x, so x squared is, well, x squared. Then you'll take your x and your negative y. Remember, that's a negative y in this quantity. So take x times negative y, that would give you negative xy. But then you got to negate that. So just like with the sum, you'll multiply the two terms inside the first factor and then you'll negate it. So this would turn into plus xy. And then you'll take that last term of negative y and raise it to the second power. You would get positive y squared. So this would factor into x minus y, that quantity, times x squared plus xy plus y squared. So let's do some examples here of some sum and difference of cubes. And they could be in any random order. They could be mixed up. Really, a sum and difference of cubes are done the same way. It's just one's plus, one's minus. That's all. But they're handled the same way. Alright, so let's say we have x to the third minus 8. We've been given x to the third minus 8. So our goal is to factor x to the third minus 8. Well, of course, to get your first factor, you're going to want to take, what's the cube root of x cubed? That would just be x minus, what's the cube root of 8? That would be 2. So you'd end up getting x minus 2, that quantity, times for your second factor. Take your first term of x, raise it to the second power, you'll get x to the second power. Then take your x times your negative 2, which would give you negative 2x, but then you got to negate that. That would actually give you plus 2x. Then take your negative 2 and raise it to the second power. That would give you positive 4. So this x cubed minus 8 would factor into x minus 2 quantity times x squared plus 2x plus 4. Now, your quadratic factor will never be, it never can factor. It never factors. You'll almost always either have to use quadratic formula, or if you're lucky for one like this, you could do completing the square to solve for the zeros, but usually got to use the quadratic formula to figure out your quadratic solutions. So that'll tie in though when we go to solve, when we solve polynomial equations by factoring. But that's for another lesson. Okay. What if we have a sum of cubes this time. We have x to the third plus 64. So we've been given x to the third plus 64. How are we going to factor that? Well, for your first factor, what's the cube root of x? That's just x plus what's the cube root of 64? Well, that'd be 4. Now, to get your second factor, take your x, take that to the second power. You would end up getting x to the second power. For your next term, multiply x times 4, you would get 4x, and then you got to negate that. So that would actually turn into minus 4x. And then take that plus 4, raise it to the second power, you would get plus 16. So that x cubed plus 64 is going to factor into x plus 4 quantity times x squared minus 4x plus 16. And if you FOIL these out, you would get that x cubed plus 64. All right. 216 x to the third plus 1. So they just threw in something a little bit different here. So we have 216 x to the third plus 1. So let's factor this here. So, all right, so what is the cube root of 216 x to the third? That would be 6x. So 6x is the cube root of 216 x to the third. Now, what's the cube root of 1? Well, just 1. So you'll get a factor of 6x plus 1 for your linear factor. Now we got to form the quadratic factor. So you'll take your first term, that's 6x, you'll square it. You should get 36x squared. Now, for your next term, take your 6x times 1 and then negate it. You would end up getting minus 6x. Then take your 1 and square it, you would just get plus 1. So 216x to the third plus 1 would factor into the quantity of 6x plus 1 times the quantity of 36x squared minus 6x plus 1. I got about 5 more, then we're done. All right, difference of cubes. 125 x to the third minus 8. So we have 125 x to the third minus 8. Well, let's form our first factor, the linear factor. So take the cube root of 125 x to the third. That would just be 5x. Now we'll do minus, what's the cube root of 8? That would just be 2. So you have a linear factor of 5x minus 2. And then now we got to get the quadratic factor. So take that 5x, raise that to the second power. You should get 25x to the second. For your next term, take that 5x times negative 2. That would give you negative 10x. Then you got to negate that. That would actually give you plus 10x. Then take that negative 2, raise it to the second power. You would get plus 4. So now this is completely factored. So you'll get the quantity of 5x minus 2 times the quantity of 25x squared plus 10x plus 4. And as you're starting to see, sum and difference of cubes really basically work the same way. It's just when you go to negate in your first quantity, whether you end up with a positive or negative middle term for your second quantity, for your second factor. That's all that is. 4 more. Good one. We have 1000x cubed plus 27. So we've been given 1000x cubed plus 27. So let's find our linear factor first. So take the cube root of 1000x cubed. That would just be 10x. That would give you 10x plus what is the cube root of 27? That'd be 3. So your linear factor is 10x plus 3. Now we'll find the quadratic factor. Take that 10x, raise it to the second power. You would get 100x squared. Now take that 10x and multiply it by 3. What do you get? You get 30x. Then you negate that. You would actually get minus 30x. Then take your positive 3, raise it to the second power. You get plus 9. So the 100x to the third plus 27 would factor into the quantity of 10x plus 3 times the quantity of 100x squared minus 30x plus 9. Three more. So we have 27x to the third plus 216. So we have been given 27x to the third plus 216. Well, let's start out with our linear factor. So what is the cube root of 27x cubed? That's going to be nothing more than 3x plus what's the cube root of 216? That'd be 6. All right. Which I'm going to suggest something here. Well, no, we can't because we still have to do the quadratic factors. Okay, so what is 3x squared? That's going to be 9x squared. Now take 3x times 6. That would give you 18x. Negate that, you'll get minus 18x. And then you'll end up taking, of course, 6 to the second. That'd be plus 36. But are we done yet? We're actually not done yet because you have to factor this completely. Let's break this down here. In your first factor, you have a common 3, right? This would factor into 3 times the quantity of x plus 2 times your second quantity of 9x squared minus 18x plus 36. Well, your first factor is completely factored, but what about your second factor? You definitely have a common 9, don't you? So factor out a 9. If you take 9 times 3, you'd actually end up getting 27 times the quantity of x plus 2 times, then you would end up having x squared minus 2x plus 4. So the complete factorization is going to be 27 times the quantity of x plus 2 times the quantity of x squared minus 2x plus 4. And that's as far as we can go. All right. I got two more. Oh, good one. 32x to the third minus 4. That looks really bad, doesn't it? 32x to the third minus 4. Well, it's true, 32 and 4 are not perfect cubes, but what can we do? We can definitely factor out a common 4 between those, right? Let's start there. If you factor out your common 4, you'll end up getting 4 times the quantity of 8x to the third minus 1. Now we have the difference of two cubes. Now we can make it work. Alright, so keep that 4 on the outside. We still need to find a linear factor. So what's the cube root of 8x to the third? That would just be 2x. Minus the cube root of 1, that would just be 1. Now, for your linear factor, to get the quadratic factor, take that 2x, raise it to the second power. You would get 4x to the second power. Now take your 2x times negative 1, you get negative 2x. Negate that, you would actually get positive 2x. Then take that negative 1, raise it to the second power, you would get plus 1. So the complete factorization of this is going to end up being 4 times the quantity of 2x minus 1 times the quantity of 4x squared plus 2x plus 1. And I got just one more and we're done for the day. Alright, so we have 2x to the third plus 54. So we've been given 2x to the third plus 54. Well, to start with, the 2 and 54 are not perfect cubes, but they both have a common factor of 2, right? So why don't we factor out 2? If you do that, you'll get 2 times the quantity of x to the third plus 27. Now, inside the parentheses, we have 2 perfect cubes. Let's go ahead and deal with factoring that. So keep your 2 outside the parentheses. What's the cube root of x cubed? That's just going to be x plus what is the cube root of 27? That would just be 3. So there's your linear factor. Now to get your quadratic factor, take that x and raise it to the second power, which will give you x to the second. Then take x times 3, which gives you 3x. Negate that, you actually get minus 3x. Then take your 3 and square it, you would get plus 9. So the complete factorization would end up being 2 times the quantity of x plus 3 times the quantity of x squared minus 3x plus 9. So as you see, sum and difference of cubes almost work the same, and they really aren't that hard. Not at all. Now the next lesson we are going to talk about factoring by grouping. This is another method for dealing with polynomial functions to factor. So I hope everyone has a great night. Take care.